Hello, hi everyone. Welcome to the Student the Brand. So this is our Siva sir. Today we are going to discuss about electric current. Electric current is nothing but rate of law of charge. So electric current we are going to discuss, right? Electric current. Electric current. The rate of law of charge is called electric current. I equal to Q by T. I equal to Q by T. I equal to Q by T. SI unit of current is ampere. SI unit of current is SI unit of current is ampere. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of charge is coulomb. SI unit of time is second. Okay. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. That is electric current. So I equal to Q by T. I equal to Q by T, right? So here 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. Now here inside of the conductor, charges are moving. So number of charges, positive charges are there, negative charges are there. Positive charges are there, negative charges are there, right? So positive charges will be considered as the positive charges. Positive charges is considered as the protons. Negative charges will be considered as the electrons. Positive charges I'm considering the positive charges. Positive charges are protons I'm taking. Negative charges are electrons. So number of charges are moving inside of the conductor. Number of charges are moving inside of the conductor. That's why I'm considering Q equal to plus or minus Ne. Plus or minus Ne. So if only one electron will move, we can't say current is flowing. Only two electrons flowing also, we can't say current is flowing. Yes or no? There are many charges. Many charges are moving inside of the conductor. So then only we can able to say current is flowing inside of the conductor, right? So that's why Q equal to plus or minus Ne I am considering. N is the number of charges are moving inside of the conductor, right? So Q equal to plus or minus Ne. On one electron, on one electron, on one electron we can take 1.6 into 10 power minus 19 coulomb on one electron. So how much charge is present on one electron? So based on this one question will come, very very important question. On one electron 1.6 into 10 power minus 19 coulomb. So in 1 coulomb how many electrons are present? So this derivation is very important at the same time. Okay, so like in the form of question, this they will ask how in 1 ampere of current. So 1 ampere of current is flowing inside of the wire. Okay, so per unit second, number of electrons are present, or one electron. So on one electron also they won't give. So this value also they won't give. So they will ask to find number of electrons are flowing. 1 ampere of current is flowing through the conductor per second. Find the number of electrons. So find the number of electrons. That is the question. Find the number of electrons. So if you want to find the number of electrons, if you want to find out the number of electrons, okay. So we have to use this formula, that is in 1 coulomb 1 by 1.6 into 10 power minus 19. Okay, so 10 by 10 if you do it, 10 by 10 if you do, you will get it here. 1 coulomb if you are taking, So in 1 coulomb, so 10 by, so 1.6 into 10 power minus 19. Then 10 by, sorry, here 6. Anyway, we are removing your 10, right? We are removing 10. Then you will get 16. 16 will get, even in plus will get 16 plus, because if this goes up, so 1 by x power minus 2 will get x square. 1 by x power minus 3. 1 by x power minus will get x power plus 3, right? So similarly, if the 1 by 10 power minus 90, if you go out, so if it is goes numerator, we'll get it 10 power plus 90. So 10 by 16, if you do it, 10 by 16, if you do it, you'll get it 0.625. So you'll get 0.625. 0.625 into 10 power 19 in 1 coulomb. So that is 6.25 into 10 power 18 electrons. So in 1 coulomb. So very, very important. So related to this one question is there. We'll discuss that one. So very important question. And related to that one, so related to SI unit of current, SI unit of charge, SI unit of time. Okay, so any system, SI unit of time is same only. So if you take any system, SI system, CGS and FPS, any system if you take, so time is same. Okay, SI unit of time is same. Now the question is related to this one, related especially, how much is the charge of an electron? Can a charge less than this value exist? So here they are asking, so how much is the charge of an electron? On electron, how much charge is present? 1.6 into, so this one is there, 1.6 into 10 power minus 19 coulomb. On 1 electron, how much charge is present? On 1 electron, 1.6 into 10 power minus 19 coulomb. Okay, so less than this value exists. No, so this value is same, fixed. And how many electrons constitute in 1 coulomb of charge? So this is the question. In 1 coulomb of charge, how many electrons are present? In 1 coulomb of charge, how many electrons are present? So in 1 coulomb, 6.25 into 10 power 18 electrons are present. Okay, so this value. In 1 coulomb, 6.25 into 10 power 18 electrons are present. Okay. Define electric current and SI unit of electric current is. Define electric current. The question is define electric current. So we have to define this one. So what is that one? The rate of flow of charge. The rate of flow of charge is called electric current. The rate of flow of charge is called electric current. SI unit of electric current is ampere. SI unit of charge is coulomb. SI unit of time is second. So SI unit of current is 1 ampere. SI unit of charge is 1 coulomb. SI unit of time is 1 second. 1 ampere equal to 1 coulomb per 1 second. So this is very, very important. And coming to the quantization of charge formula, Q equal to plus or minus any. Q equal to plus or minus any. So related to this one, these are the questions. And what is the relationship between 1 ampere and 1 coulomb? The question is, what is the relationship between 1 ampere and 1 coulomb? 1 ampere and 1 coulomb. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. Net charge we are taking, so net charge. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere equal to 1 coulomb per 1 second. That you can write, right? Yes. Okay. So next one. And one more question related to this one I will explain. I already said this question, but still once again I will read out. The charge possessed by an electron is 1.6 into 10 power minus 19 coulomb. The charge possessed by an electron is, so they given this one, 1.6 into 10 power minus 19 coulomb. Find the number of electrons that will flow per second to constitute a current of 1 ampere. So just now I said, right? So in 1 ampere of current, So in 1 ampere of current is flowing in the conductor. Okay. Find the number of electrons. Find the number of electrons. They are asking to find the number of electrons. So charge is given. Charge of an electron is 1.6 into 10 power minus 19 coulomb. Sometimes they didn't give, so they won't give this one. So they will not give this value. So you have to remember. You have to remember this value 1.6 into 10 power minus 19. Okay. So that's enough. And coming to the one more question related to this. Uh, so I'm not getting time to practice, give practice questions. So that's the reason I'm reading out now itself. Just go through it. Okay, so related to electrical appliances, electrical, and one more question also there. So that is a number of electrons they will give, and anyway, on one electron, how much charge is present that we know. So, and in 1 second, that question also very important. That is once again, number of electrons they will give like 6.6 into 10 power 46 like that. Number of electrons they will give. Okay. So and the charge of an electron anyway we know charge of an electron is how much 1.6 into 10 power minus 19 coulomb, right? So that is 1.6 into 1.6 into 10 power minus 19 coulomb. So that we know. So you can use that value and find out, right? So related to this concept, these are the questions. First question is related to SI unit of current. They will ask define SI unit of current and SI this one. SI unit of current they will ask and current definitions they will ask. Current definition and SI unit of current. Current definition SI unit of current and SI unit of current and charge and time and quantization of charge. So this is very important. Anyway, after writing, so we can write final formula that is I equal to Ne by T. Okay. So by taking this formula, we can solve few problems also. Related to these problems also they will give. Anyway, this value, 1.6 into 10 power minus 19. Okay, this value, and n value if they ask to find out, we can by using this formula we can find out. Anyway, time is 1 second, right? Time is 1 second we can take and 1 ampere. Current is 1 ampere. 1 ampere. And so electron is how much? On one electron, how much charge is present? 1.6 into 10 power minus 19 coulomb. Then we can find out number of electrons. Number of electrons. So that is a question. And now we'll go to the. So I'll explain electrical appliances. Electrical appliances. Okay. So related to electrical appliances, there is one more question. One more question they will ask. Okay, by 1 minute. So positive terminal, negative terminal cell coming to the battery. So third one is switch. Fourth one is closed switch. And fifth one is about resistor. So resistor we are discussing. Resistor. Open switch, closed switch, this one. Closed switch. Open switch. Okay, so battery. So cell. And the sixth one is rheostat. Rheostat. Okay. So this is the rheostat. Once again, cell, battery, open switch, closed switch, resistor, rheostat, ammeter, and eighth one is voltmeter. Voltmeter. Ninth one is wire joining. 10th one is wire crossing. And 11th one is bulb. This is bulb. Okay, once again, cell, battery, open switch, closed switch, receiver, rheostat, ammeter, voltmeter, wire joining, wire crossing, and bulb. Here you can observe one thing. Resistor. Resistor is a device which is used to oppose the electric current in the circuit. Resistor is a device which is used to oppose the electric current in the circuit. So we are using, so it is a device. If you connect, so I'm considering this is the resistor. If you connect in the circuit, okay, so it opposes. Even you can see the bulb, okay, whatever the devices you are connecting in the circuit, bulb, like TV, and so fan, like this all are resistors only. So whatever the current is required to them, so remaining current it will allow to pass in the circuit. Okay, whatever the current is required, that only they will allow. Remaining current it won't allow. More current it won't allow to go inside of the devices. Okay, some appreciable resistance will be there. Some appreciable resistance. It completely does not no, oppose. So some appreciable resistance is there. That's why it is called resistor. That's why it is called resistor, right? Resistor is a device which is used to oppose the electric current in the circuit. That is called a resistor. Resistance is the phenomenon. So 3 points I will tell. Very, very important points I am saying. First one is resistor. Okay, second one is resistance. And third one is ohm. And fourth one is symbol. Okay, so related to resistance, resistor is a device which is used to oppose the electric current. Resistance is a phenomenon of opposing the electric current, and the SI unit of resistance is ohm. Okay, so resistor is a device which is used to oppose the electric current. Resistance is a phenomena of opposing the current. SI unit of resistance is and a symbol. Symbol is, so this one is the symbol. Okay, done. Now ammeter. Ammeter is used to measure the electric current in the circuit. Ammeter is used to measure the electric current in the circuit. Used to measure the electric current in the circuit. So here, first point is current. First one is current. Second one is ammeter. And third one is series combination. Okay. So and fourth one is ampere. Ampere we have to take. And fifth one is symbol capital A. So these 5 points, related to these 5 points I want to discuss. Once again you can see current. Current is a physical quantity. Current is a physical quantity, okay, which can be measurable. Which can be measurable. Ammeter is a device which is used to measure the electric current. Ammeter is a device which is used to measure the electric current. So ammeter is connected in series combination to the circuit. Ammeter is connected in series combination to the circuit. SI unit of current is ampere. So ampere you have to write a small letter. So starting you have to write small letter. Okay. So we should not write capital letters ampere. That is wrong. So we should not write like this. So we should not write like this. This is wrong. So we have to follow the small letter on honoring the scientist. We are writing ampere and symbol of ampere is capital A. So we can use capital letter A for representing ampere, SI unit of current. Alright? Okay, done. Now, so that is about current. And coming to the potential difference, potential difference is nothing but SI unit of, potential difference. Potential difference. First point. Coming to the second point is volt, and third one voltmeter. Voltmeter, and fourth one is parallel. Okay. So SI need potential difference is the physical quantity. So physical quantity is the potential difference. SI unit of potential difference is volt. So voltmeter is used to measure the potential difference. Voltmeter is used to measure the potential difference. Parallel combination, right? Yes. I hope it is very clear to you all. Now, so wire joining, wire crossing, bulb. So these are the electrical appliances. Electrical appliances. I hope it is very clear to you all. Next. Electrical circuit. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. Okay. So now we'll discuss about electric circuit. Electric a electric circuit. A continuous and closed path of an electric current is known as an electric circuit. An electric circuit. So I am taking here, this is the battery. This is a battery I am taking. Okay. So here switch. Now ammeter. Next one is the bulb. So current is flowing. So positive terminal, negative terminal, bulb is glowing. Now we will discuss about electric circuit. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. Here 2 points. So we need to discuss 2 points. Those are point number 1, conventional current. Point number 1, conventional current. So what is a conventional current? Conventional current. And the second one is electric current. Conventional current and electric current. We'll discuss conventional current and electric current. Electric current. Sir, what is the meaning of conventional current and what is the meaning of electric current? Conventional current is nothing but the flow of positive charges. So the flow of positive charges is known as conventional current. The flow of positive charges is known as conventional current. The flow of electrons is known as electric current. So here you need to understand one thing. Positive charges will move from positive terminal to negative terminal. Electrons will move from negative terminal to positive terminal. Once again, listen carefully. Very, very important point. So one question will come on this. So very, very highly important point. That is, positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. So and positive charges will move from high potential to low potential. Electrons will move from low potential to high potential. So point number 1. So here are 3 points we have to remember. Point number 1 about definition. So regarding definition they will ask. Point number 2 regarding the high potential to low potential or low potential to high potential. And coming to the third one, direction of positive charges. So direction. So related to these 3 questions, they will ask. So definition. Okay. So point number 1, definition. The flow of positive charges is known as conventional current. The flow of electrons is known as electric current. So point number 1. Point number 2. So positive charges will move from high potential to low potential. Positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. And direction. The third point is about direction. So the flow of positive charges will be considered as a conventional current direction. the flow of electrons direction will be taken electric current direction. Okay, so these 3 points, so based on these 3 points they may ask the question also, they will ask the questions. So be careful, so be careful while you are reading these questions, while reading this concept. Okay, so concept electric current, we have to remember conventional current, electric current definition you have to remember. And so positive charges will move from high potential to low potential, always you have to keep in mind that point is, so positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. Very very important, very very important, make sure that you are so remembering this point. Okay, so definitely one mark question will come on this, so I am very sure about it. So expected 1 mark question on, so charges, electrons will move from high potential to low potential or low potential to high potential, so like that they will ask the question. Okay, and anyway direction, conventional current direction is positive charges direction, and electric current direction is so negative charges, that is negative terminal to positive terminal, right? I hope it is very clear this concept. I am moving on to the next topic, that is electrical potential and potential difference. Electrical potential and potential difference, right? So we'll discuss about potential difference and electrical potential. Potential difference. Potential difference and electrical potential. Sir, what is potential difference? What is potential difference? Potential difference is nothing but, okay, charge is there. So one point, another point I'm taking here. So this is the within the conductor. This is one point A and a point B. Okay, so this is the charge. We are doing some work. We are doing some work to bring unit positive charge from one point to another point. We are doing some work to bring unit positive charge from one point to another point within the conductor. Within the conductor is called potential difference. So V equal to W by Q. V equal to W by Q. So what is SI unit of potential difference? SI unit of potential difference is volt. SI unit of work is joule. SI unit of charge is coulomb. SI unit of charge is coulomb. Okay. So what is the potential difference? Once again, so I'm repeating. So once again, listen carefully. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. SI unit of potential difference is volt. SI unit of work is joule. SI unit of charge is coulomb. Coming to the electrical potential. Electrical potential.